Well, welcome to another video on the analog discovery. This is not going to be out of the Art of Electronics book as some of my previous ones have been. This is another toy. I call it that because I generally refer to all of the things that I buy as toys, even the many $1,000 spectrum analyzers and oscilloscopes and things of that sort. But this is certainly nothing in that dollar range. What this is a curve tracer for the analog discovery. It's available on Tindy. It's made by a gentleman or a group of people, I'm not sure. His name is Ilya, at least he's the person who contacted me about this, from the Netherlands. I ordered this 15 days ago. It arrived yesterday, so it took almost exactly 2 weeks, actually 2 weeks and a day, because I actually ordered it 2 weeks ago yesterday, or day before yesterday. So at any rate, what it's showing is the collector voltage versus collector current for a variety of base currents. And the transistor that is displayed is a 2N3904. And this is not intended to be a review of the curve tracer, partly because I'm still playing around with it. The directions online are sparse, and none came with the device. I did buy the device from Tindy, which is the supplier or the marketer, I guess. But at any rate, full disclosure, Ilya had offered me a free curve tracer. I declined and purchased it myself, and in a minute you'll see it's very cheap with shipping and everything. It was less than $20. This, for example, is a higher base current than this, and so on. If you're not familiar with curve tracers, I did a video, I guess maybe a year ago or so, and a little bit later I'll try to get you the number on that one. And this board, essentially, based on what I can tell, is just an implementation of what I showed in that video a year or so ago. Nonetheless, it is convenient to have it all on a board, and as we'll see in a minute, it has a little, you can buy it with a little ZIF socket and other things that make it a little more convenient. And it also comes with a script that runs the waveform generator and the oscilloscope. And if you've seen my previous video, you know that you can set that up yourself if you want to. But basically what it does is it applies a stair step. That's this orange step here. It applies a stair step to the base. And then, of course, during that time, it sweeps the collector voltage and measures the collector current. So because of limitations in the analog discovery, it can only go up to about 5 volts. But that's something which was true of my design as well. Now, one thing that could be done, and I'll talk about this at the end, is you could add, or perhaps even the developers might want to consider, the people who put this circuit onto this board, adding a voltage, a DC to DC converter to allow you to use higher collector voltages than 5 volts. But nonetheless, this is a 2N3904. Now, let me show you what you can do. I am now going to be moving over to the right, and let me Well, this is not going to work very well. Let me try to set this up a little differently. Over here on the right are the voltage and current settings for this. And what I'm going to do is I'm going to change from 5 milliamps per division to 2 milliamps. And then I'm going to change the offset to, let's make it minus 5 milliamps. And then I'm going to change the voltage from 100 millivolts per division to 200 millivolts per division, and I'm going to change the offset to minus 1 volt. Okay, now what you'll see over on the left is more of the curves. Now, all I've really done is just change these values to optimize the display for this 2N3904 that I'm using. It spreads it out a little more and makes it a little bit easier to see and to read, but really I didn't change anything else. So in a second I'll show you how you run this from the stopped position. So let me restart waveforms and then I'll be back. Okay, now I'll come over here and click on waveforms. And you notice that the waveforms window comes up, and at the top here is the workspace, the DWF3 work. That is the common designation for a saved workspace in the waveforms. And I'm going to click on that, and you'll notice that what comes up is a script. Then, if you and you may notice that the WaveGen right here is not running and the supplies are not running. Now I'm going to click on Run for the script, and you may see the WaveGen comes on, the supplies come on, and the little green scope symbol blinks to show you that it's finished. Then you click on Scope, and you get the display that we saw earlier. Now, once again, you can adjust your voltage and current figures to make the display a little more or less convenient depending on your preference. But now what I'm going to do is I'm going to put a 3906. This is a 3904, which is an NPN transistor. So I'm going to put a PNP transistor in the socket and see what we get there. And here are the curves for the 3906. Once again, I'm going to go over here and change the range from 100 millivolts to 50 millivolts. I am wrong. I want 200 millivolts. And I'm going to change the current range to 2 milliamps per division. And the offset to minus 1 volt, and the current offset to minus 5 milliamps. And you see the curves that we get there. However, unfortunately, you don't get this if you run the script. In other words, what I've found is that the script, at least the way I'm using this device, only works for an NPN transistor. Now, I haven't tried JFETs and diodes, which on their website they advertise that it will also do those. I've basically just been going back and forth between the 3904, the NPN transistor, and a 3906, a PNP transistor. Okay, I was able to get it to work, so how did I do that? Well, let me first close waveforms again. Reopen it. Reload the curve tracer script. Run it. Wait for the scope to turn green, and then click on scope, and you'll notice that I get an incorrect trace. Well, I will tell you one thing that I've done that's different. I have reversed the base and collector of the 3906 because that's what it takes to make it work. In other words, you put the 3904 in one way, you put the 3906 in the other way. In a minute I'll show you what that means in terms of the physical situation. However, then you have to go to the WaveGen window and come down here to the amplitude of the steps. And you notice that here the steps are starting at the bottom and going up to plus 5 volts. You have to change that to minus 5 volts. Now you notice the steps start at 0 volts and go to negative 5 volts. Now if I go back to the scope and I press config, now let me make it clear, you do not go back and rerun the script. You have to press config and then start. And there you get the curves. Now once again, as I pointed out, you can adjust the offsets and the ranges to make this display a bigger picture and so on. But here's the important point. As the curve tracer and the script come from the manufacturer, it will test an NPN transistor directly. But if you want to use a PNP transistor, you have to do two things. One is you have to reverse the way you insert the transistor in the ZIF socket. Once again, I'll show you that in a second. And you have to change the polarity of the step signal so that instead of going from 0 to 5 volts, it goes from 0 to negative 5 volts. Now let me show you what happens if you just run the script. Wait for the scope. And you'll notice you're back where we were. What happens is the script is setting the waveforms, let's go over there and we'll see, is setting the WaveGen back to plus 5 volts. Now we're going to change that back again to minus 5 volts. And this is why I said earlier that you can't go back and run the script again because it'll just set it back where it was. Instead, you have to go to scope and click on config and then start. And when it completes, you'll get your curve trace. Now, I suspect, frankly, this was an issue that I faced when I first put this curve tracer idea together a year or more ago, is that you would have to, and I mentioned in that video, you'd have to provide some switching and other things so that you either have to put something in the script that senses the transistor, which kind of transistor you have, and then changes everything around, including the connections. And let me show you physically what you have to do with the analog discovery. Here is the analog discovery, and in the ZIF socket, you may be hard to see, I'll zoom in a second, is the 2N3906. And you may not be able to see this, but the flat side is on the side with my finger. In other words, it's facing out. The flat side is facing out to the right. To make the 3904 work, and to make it work the way that it comes with the script, with the 3904, you have to have it in the other direction. In other words, you have to have the flat side over there. Now, I haven't changed the 3906, and we'll swing over here quickly to the screen, and you see there's the 3906. Now what I'm going to do is configure the 3904. Well, first let me zoom in and show you the proper placement for a PNP transistor. Hope this will show. Well, it looks like it's not going to want to focus that closely. There. Well, I think that's about got it. That's pretty close. I think you can see, let me rotate it, maybe it'll show up a little better. You can see that the flat side is to the right there. So now let's put in the 3904 and do the same thing. Now I hope you can see that the flat side of the 3904 now is facing to the left as this board sits on the analog discovery. In other words, on the side with the finger here. Now we'll go over and look at the screen. Now I have not rerun this, so this is basically the same, pardon the motion sickness inducing camera work here. Now what I'm going to do is rerun config over here with the negative values and everything reversed. You notice you get nothing, but if now I go over to the script and rerun it, wait for the scope, you see that we do get the proper traces. So in other words, what I'm saying is you have to invert the base or the collector and emitter leads in the ZIF socket by turning the transistor 180 degrees, and you have to invert the wave gen steps so that instead of going from 0 to plus 5 volts, it goes from 0 to minus 5 volts. Frankly, I anticipated that when I saw this particular design because it's fundamentally just the same design that I showed in an earlier video put on a board. Sorry for the break. I had to meet with the guy that does our yard. My wife normally takes care of that, but she's off with her sister this morning doing a, I guess you might call it a mall crawl. Actually, they're looking at all of the half-price places, the junkyards and Goodwills and so on. Anyway, what I wanted to say is, I consider the convenience of having the ZIF socket and the connector and everything so that all you have to do is plug it in as being worth the price. But you might want to consider that at least in its current configuration, all that this board does, at least as far as I can tell, is it sets everything up for an NPN transistor. But you're still going to have to make some changes, like turning the transistor around and adjusting the wave gen polarity and so on, if you want to test or you want to curve trace PNP transistors. The limitation of the analog discovery to only 5 volts, though, has always been what I consider to be the limitation of this whole technique. And I mentioned that back when I did the original video. By the way, I said I would get that number, so let me do that. Okay, this is the Tindie website. If you look for Curve Tracer on tindie.com, Tindie. And by the way, I don't have any connection with Tindie or the developer of this. His first name is Ilya. There's the Tindie logo. And here is the curve tracer itself. I'm going to click on that. Currently it says it's $12. The how to use is here on the website, so I won't repeat that. The product spec is, or the product page is here, but basically this is the AD2 Analog Discovery 2 add-on board, add-on curve tracer board. There's the description up there. And like I say, it currently costs $12 plus shipping. It took about just over 2 weeks from the time I ordered it. They shipped it right away and arrived fairly quickly. So I'll let you be the judge of whether this is something you want to add to your analog discovery. It's fun to play with, but I have to say, as I said in that video 179 some months or a year or so ago, it's a little bit of a toy, in part because the analog discovery will only let you use 5 volts. So it won't work very well for power transistors or for higher voltages than 5 volts. It will give you an idea of the characteristics of a small signal transistor. I have fun with things like this, but you should make your own decision. And as I say, I don't consider this a full-fledged review, but rather a kind of a first look, in part because, except for the instructions that I showed you that are down below here in the website, I have not found any instructions. I sent a message to Ilya to see if there were any other instructions, and have not yet received anything back. Okay, it looks like this is the seller's picture over here. This must be Ilya. So anyway, enough blathering. Let me say that for what it is, I think it's worth the $12 for me, but I'll let you make your own decisions about that based on what you've seen. If you're willing to make a few changes here and there, it is something that can be fun to play with, but there obviously are some improvements that could be made, at least in my opinion. So, hope you've enjoyed this, and once again, that you'll stay tuned for some future videos. Maybe we'll be able to get back to some art of electronics projects, but in the meantime, have a nice day.